Okay, this is example 5, and this problem says to use the data from example 5 from section 4.4, and the sample is below here, and it says the sample below is for the cost of 22 2-liter bottles of Pepsi, and is the data approximately normally distributed? If so, what is the probability that the mean price for the sample of 22 bottles of Pepsi is between $1.14 and $1.17, given that the population mean is reported to be $1.18? So let's see what the situation is here. Is we have this raw data. Well, before we can use Z and or T scores, we have to get the standard deviation. So we'd have to put this data into the raw data sheet, and I'll click on that, and I already have my raw data typed in here. So now that I have my raw data in here, I can get my sample standard deviation. So my sample standard deviation for this raw data is given right here to be 0.0356. So that's the value that I will use for the S on the ZNT sheet. So on the ZNT sheet now, on the second section, and it's the area between two values, put that 0.0356, I think it was. I'll show you that value again on the raw data sheet right here, 0.0356. And really what I did was I copied it and pasted it as just values into the ZNT sheet. So that's that value right there. It just rounded it up. Here's all the values from the other sheet. When you do the copy and paste, you get it very exact. Then put in your sample size, and it was said that there was 22 bottles of Pepsi here, or you could count them up, and there's 22, so put that in here for the N. And it says the probably that the sample mean price of these is between $1.14 and $1.17. So your lower X value or your lower X bar value is $1.14 and your higher is $1.17. And it says given that the population mean is $1.18. So put your $1.18 right here for the mu. And then it works it out. It uses T-scores because we know the sample standard deviation, not the population standard deviation. And then at this point, the probability between these two values is 0.100, or about a 10% chance. And you can see that's the answer you get right there, 10% chance. Now, on example 6, it starts doing inverse T-score problems. And you would use section 3 of the ZNT sheet to do this. Like this first problem says with a sample size of 10, the probability that it scores between two symmetric T-scores is 95%. What are the T-scores? Well, this one gives you a probability and it wants the T-score. That's why it's an inverse T-score. So use the third section anytime you're doing inverse Z or T-scores. Put in your sample size, and for this it's 10. Right here the N is 10, and it's between two T-scores. So right here, probably between, type in 0.95 and you'll get your two T-scores. In other words, if I was asked just the opposite, what's the probability a value is between these two T-scores, the answer would be 95%. For example, I've put this value right in here for the lower T-score and the value of 2.262, and for the upper T-score with a sample size of 10, and you see the probability is 0.95. That confirms that that's what you get here. If it says, like on 6b, less than that is 0.05, then what you would do is put 0.05 right here to the left because it says less than. And this was still with a sample size of 10. So the T-score with a sample size of 10 that has 5% of your probability less than that is negative 1.8331. Again, you could check that right here. Put 10 in here. Put in that T-score of negative 1.83311, and you get 0.05 is to the left. And if it says greater than that, like part C does, example 6C is 0.01, then put in your sample size, which is still 10, and since it says greater than, put your 0.01 right here to the right, and you get 2.82. And that would be the answer to that problem. Again, you could check that up here and see if I put in 2.82, well, it's really 2.8241, you'll get an area to the right to be 0.0099, and that's because we rounded this value, but this is approximately a 10% chance right here. If I would carry more digits, it would be exactly that. So that's how you do those problems. And a more in-depth problem where you're given means and standard deviations right here with example 7. And this one says assume the price of bottles of Pepsi is normally distributed. During a certain week, the mean price of the bottles was $1.16. A sample of 10 bottles of Pepsi was taken. Sample standard deviation, notice it says the sample standard deviation of the 10 bottles was 0.2. At what range would you expect the middle 95%? So this is an inverse T problem. Use the third section of the sheet, put in your mean right here, which is $1.16. We do not know the population standard deviation, but we do know the sample standard deviation, which is S, is given to be 0.2. So type in 0.2 here. The sample size was given to be 10, so put 10 right there. And then the section here that we need to do is the middle bit, probably between, and it says the probability between is 95%. It says in what range would you expect the middle 95% of your sample means? Put 95% here, the probability between. This is the t-scores, but this is the actual dollar of amount. So this is $1.016, which rounded to the nearest penny is $1.02, and this is $1.30. So in other words, I'm 95% sure that the average of 10 bottles of Pepsi in terms of their cost should be between $1.02 and $1.30, and that would be the answer to that problem. So we'll stop this problem right here at this point.